Two-dimensional forces. Now that we can resolve a force at an angle into its x and y components, we're ready to solve more complex problems. We'll start with a review of determining an object's acceleration in one dimension due to external forces. For instance, draw the free body diagram of a box being pulled along a rough surface. Here's our box. We have mg down, normal force up. There is a force applied to the right and a force of friction to the left. And the acceleration is expected to be to the right. Now we'll find the acceleration of the box given that the applied force is 20 newtons and the box has a mass of 3 kilograms and the coefficient of kinetic friction is 0.2. So we'll solve this by doing our equations for x and y. In the x direction, there is force applied minus force of friction equals ma. Now the force of friction is mu times the normal force. In the y direction, there is normal force minus mg equal to 0. So therefore the normal force is equal to mg. M is 3 kilograms and g is 10 meters per second squared. So therefore, the normal force is equal to 30 newtons. Now it's time to find the acceleration. In order to solve for acceleration, we have to divide both sides of this equation by m. So we get A is equal to force applied minus mu times normal force divided by m. Now if we plug in our numbers, A would be equal to 20 newtons minus 0.2 times 30 newtons divided by 3 kilograms. So the acceleration A is equal to 4.7 meters per second squared.